Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through everything you need to know from our geometry topic. So I'm going to go through the topics on your screen. Let's start with angles. So there are 4 types of angles that we need to know, and we need to know these because they often come up in congruent triangles. So the first 3 all involve parallel lines, but the 4th one doesn't. So when you have a C shape like this, these 2 angles on the inside are called co-interior. Note I've used a different marking for each angle, and that's because the 2 angles that are co-interior are not equal, they're supplementary, meaning they add to 180. So if this angle was like 120, this would be 60. This angle was 130, this would be 50. That's what co-interior means. So it can be a C shape like this, but can be a back to front C as well. So this angle here and this angle here, these 2 red angles are also co-interior. The second type of angle you need to know makes a Z shape, alternate angles. So these 2 angles are actually equal. Alternate angles are equal, and just like with co-interior angles, we can have a Z shape, but it can also be a back to front Z. This angle here and this angle here in blue, those 2 angles are alternate. So they would be equal as well. So if this angle is 50, this angle would be 50. If this angle here were 130, this angle here would be 130. Corresponding angles make an F shape like this. Once again, it can be a back to front F. So like this angle here and this angle here would be corresponding. It can also be an upside down F. So corresponding angles, like alternate angles, they are equal. So if this angle here was, say, 100, this would be 100. If this was, say, 80, this would be 80. The last type of angles, vertically opposite, do not require parallel lines. So whereas co-interior angles make the C shape or back to front Z, alternate angles make a Z shape, corresponding angles make an F shape, vertically opposite have an X shape. So these 2 angles are vertically opposite, these 2 angles are vertically opposite. Vertically opposite angles are always equal, and that's very simple to prove. So I know the X and the dot, these 2 angles are supplementary because they make a straight line. They must add to 180. But I know the X and this angle add to 180. The only way that can be true is if these 2 are equal. So these 2 angles are equal, these 2 angles are equal. So let's use this to find some unknown angles in this diagram down here. So starting with W in this diagram would be equal to 100 degrees. So the reason is we have parallel lines, and W is actually corresponding to that 100-degree angle. You can see that it makes an F shape here. So W is 100 degrees, and we need to write a reason in brackets, and that is their corresponding. So let's now look at Z. So Z and this angle here, they make a C shape. Yeah, it's kind of a back to front C, but that's okay for co-interior angles. So Z and 100 are actually co-interior. So remember, co-interior angles add up to 180. They're not equal. So since this angle is 100, this would be 180 minus 100, which is 80 degrees. So Z is 80 degrees because it's co-interior to this 100-degree angle. So let's look at Y. So now we have Y. This makes the Z shape. So Y and this 100-degree angle are actually alternate. And we know when we have parallel lines that alternate angles are equal. So Y is also equal to 100 degrees. So finally, we have X. So this angle over here, hopefully you can see there's kind of an X shape made here and here. So these 2 angles are vertically opposite, and so they must be equal. So since X is vertically opposite to the 100-degree angle, X is also 100 degrees. So we're done with angles here, so please make sure you know these 4 types of angles because it makes congruence questions so much simpler. Now we're going to move on to different types of shapes. So you would already know that if a shape has 3 straight edges, we call it a triangle. So there are different types of triangle. So we have 3 names for the side name of a triangle and 3 names for the angle name of a triangle. So a triangle can have either no equal sides, 2 equal sides, or 3 equal sides. So no equal sides is called a scalene, 2 equal sides is called an isosceles, and 3 equal sides an equilateral. So note, for any triangle, the number of equal sides is the same as the number of equal angles. So if a triangle has no equal sides, it will have no equal angles. Similarly, triangle has 2 equal sides, it will have 2 equal angles. And if it has all equal sides, then all its angles must be equal. Now, because the angles in any triangle add to 180 degrees, if all 3 angles are equal, then they must all equal 60 degrees. So equilateral triangles always have 3 60-degree angles. So that's all for the side name of a triangle. We can also have angle names for a triangle. So a triangle can be, in addition to being scalene, isosceles, or equilateral, it can be acute angled, obtuse angled, or right angled. So it's acute angled if all its angles are acute, i.e. below 90 degrees. It's obtuse angled if it has one obtuse angle, which is one angle more than 90 degrees. Remember, a triangle can never have 2 obtuse angles because all its angles add to 180 degrees. And a right-angled triangle is one that has just one right angle. So let's try this question here. If I have a triangle that has one angle equal to 90, one angle equal to 45 degrees, what type of triangle is it? Well, in order to determine whether it's scalene, isosceles, or equilateral, we need to know the third angle. We need to know how many equal angles there are, because that will tell us how many equal sides there are. So since angles in a triangle always add to 180, the third angle of this triangle would just be 180 minus 90 minus 45. So actually, the third angle of this triangle is also 45 degrees. So because it has 2 equal angles, it must be an isosceles triangle. Because it has a right angle, it must be a right-angled isosceles triangle. So when you're asked what type of triangle something is, you must give angle and side name. Alright, let's now move on to different types of quadrilaterals. So classifying quadrilaterals is substantially harder than triangles. For triangles, we just classify its side name and its angle name, but that's harder when it comes to quadrilaterals. So here is sort of like a decision tree for you to determine what type of quadrilateral you have. So let's start by how many equal sides it has. So, if it has no equal sides, it's either an irregular quadrilateral or a trapezium. So a trapezium is a 4-sided shape with just one pair of parallel sides. Trapeziums can have no equal sides, or they can have one pair of equal sides, in which case we call it an isosceles trapezium. But we're mostly focused on shapes that have 2 pairs of equal sides. So if the 2 pairs of equal sides are next to each other, that's what adjacent means, then the shape is a kite. So see here, these 2 sides are equal and they're touching, and these 2 sides are equal and they're touching. That's what a kite is. But if the shape has 2 pairs of opposite equal sides, it's a parallelogram. Opposite meaning facing each other. So see, in this shape, the 2 equal sides are facing each other, whereas here the 2 equal sides were touching each other. So, rhombuses, squares, and rectangles are special types of parallelograms. A rectangle is a parallelogram that has all angles equal, so they'll all equal 90 degrees because angles in any quadrilateral add to 360. So a rhombus is a special type of parallelogram where all sides are equal. See, in a normal parallelogram, these angles don't have to be equal, and these sides don't have to be equal. So if you have a parallelogram with all sides equal, it's a rhombus. All angles equal, it's a rectangle. A square is a type of rhombus and rectangle. It's a parallelogram that has all sides equal and all angles equal. So make sure you get these definitions right, because people often mess these up. For example, people think if you have opposite sides equal, it must be a rectangle, but that's not true. To be a rectangle, it would also need to have all angles equal. Similarly, people often think if you have a quadrilateral with all 4 sides equal, it must be a square. But that's not true. A square must also have all 4 angles equal. So please make sure you understand the proper definitions of quadrilaterals. All right, let's now move on to transformations. So when we're talking about transformations, we're talking about translations, reflections, and rotations. So make sure you use these names. Yes, a translation is when you slide a shape, a reflection is when you flip a shape, and a rotation is when you turn a shape. But you need to use their proper names: translation, reflection, rotation. So I've taken this shape here, ABC, this triangle, and I've translated it, rotated, and reflected it. So if you translate a shape, for example, you also translate the vertices. So vertex A would move here, so I put an A dash to indicate this is the image of A. A has gone from here to here, and then we'd have B dash and C dash. If I rotate this shape, then the vertices will also be rotated. So I'd have vertex A moving up here. A vertex just means a corner, by the way. B would move here, and C would move here. So if I reflect this shape, I'll also reflect the vertices. So A would be down here, B moves to here, and C moves to here. So all you need to know out of this is just what a translation, reflection, and rotation are. So the reason that we went through this again is if you translate, rotate, or reflect a shape, or perform multiple of these, like translate and then rotate it, if you do that, the new shape you get is congruent. All 4 of these shapes are congruent to each other. That means they have the same side lengths, the same angles, the same area, and everything. It means that any of these could be rotated, reflected, or translated to go back on top of this. All 4 of these are essentially the same shape, and that's what congruent means. So let's look more at congruent triangles. So I just told you that 2 shapes are congruent if they have the same side length, same angle, same area. But when it comes to triangles, we don't need to check all of that. We don't need to check every pair of sides and make sure it's equal, every pair of angles, make sure it's equal. In order to determine whether or not 2 triangles are congruent, we can just use one of these 4 tests. If any of these 4 tests works, just one of them is all we need. If any of these 4 tests works, then the 2 shapes are congruent. So these are the 4 tests: SSS, RHS, SAS, and AAS. So SSS is pretty simple. It just means when you have the 2 triangles, pairs of corresponding sides are equal. In other words, they have the same set of side lengths. So RHS is a little more complicated, because it's very specific what we need to have. We need to have a right angle in both triangles, so a 90-degree angle, that's the R. The H stands for hypotenuse, so that's the longest side of the right angled triangle. It's always opposite or facing the 90-degree angle. And then the S means we need another side. So to use the RHS test, we need 2 right angled triangles. Their longest sides must be equal, and another pair of sides must be equal. So unfortunately, the last 2 tests are a bit more complicated. So SAS involves 2 pairs of sides and an angle, but it has to be the angle in between the 2 sides. So these 2 triangles here are congruent by the SAS test. So please don't think just because you have a right angled triangle, you must use the RHS test. Here, I haven't told you that the hypotenuses are equal. Instead, we have 1 pair of sides, 2 pairs of sides equal, and then the angle in between them is equal. That's what I mean in between. It's got to be the angle that's touching the 2 equal sides. That's the SAS test. The AAS test is a bit more complicated as well. Now, it involves 2 pairs of equal angles and a pair of sides. But the pair of sides must be corresponding. They must be matching. They must be in the same place. So what I mean by that is it has to be like the 2 longest sides or the 2 shorter sides that are equal. Otherwise, you can't use the AAS test. So in these 2 triangles, I have 2 pairs of equal angles, and these sides are corresponding. These sides are matching up because they're both opposite or facing the 80-degree angle. Now, it turns out in any triangle, the longest side is always opposite the largest angle. So in this triangle, of course, the third angle would have to be 40 because angles in a triangle always add up to 180. This is the largest angle in both triangles, so the side opposite must be the longest side. These two sides are corresponding. Firstly, they're both opposite the 80-degree angle. Secondly, they must be the longest side in their respective triangles. That's why the AAS test works. All right, let's now look at choosing which of these tests we would use. So here we have lots of pairs of triangles. We're going to determine whether or not they're congruent by looking at the tests we went through on the previous slide. So firstly, let's look at these two triangles here. So let's just ask ourselves, what do we have? Well, we have one pair of right angles, we have a second pair of equal angles, and we have one pair of sides. So if I was going to use a test, the only test that would work is the AAS test. So you can see I have two pairs of equal angles, and I have the corresponding side. I have the side opposite the dot. So just note, when we're looking at congruent triangles, if two angles are marked with the same thing, it means they're equal. Two sides marked with the same number of dashes, it means they're equal. So these two sides are equal, these two angles are equal. So I have two pairs of equal angles, and these two sides are corresponding because they're both opposite the dot. So these two triangles are congruent by the AAS test. So yes, they're congruent, it's the AAS test. So let's look at these two pairs of triangles. Well, these are clearly not congruent because they are different sizes. You can't have two triangles being congruent if they're a different size. Now, they have the same set of angles. These two triangles are both equilateral. So all angles would be equal to 60 degrees, but just having all equal angles is not enough to prove congruence. They have different side lengths, and so the answer is no, they are not congruent because they have different side lengths, even though their angles are the same. So let's look at these two triangles here. Now, a lot of people would look at these and say, okay, they can't be congruent because they have different angles. But let's look at the missing angle in each. So 70 plus 50 is 120, so the missing angle here must be 60 degrees. And here 70 plus 60 is 130, so the missing angle must be 50 degrees. In fact, these two triangles have the same sets of angles. So that's not enough though, just having the same set of angles. We also need a corresponding side to use the AAS test. So they have the same set of angles. Now notice that this side is equal to this side. It's just marked for you. This side is opposite the 50-degree angle. This side is opposite the 50-degree angle. Because both of these sides are opposite the smallest angle, this would actually be the shortest side of this triangle, and this would be the shortest side of the other triangle. So what I'm saying is these two sides are corresponding because they're both the shortest side. They're both opposite the 50-degree angle. So we have two pairs of equal angles. We actually have three pairs of equal angles and a pair of corresponding sides. These two triangles are congruent by the AAS test. All right, so looking at this, so here we have two pairs of equal sides. So that's not enough to prove congruence on its own. But what you know from the first slide is that these two angles here are equal because they are vertically opposite. So what I have is two pairs of equal sides, and the angle between them is equal. So this is an example of the SAS test. This triangle and this triangle would be congruent by the SAS test. So let's look at these triangles here. I have two triangles. So these have a common side. So this side is equal in both triangles. They also have a right angle, and these two sides are equal. Remember, this is the hypotenuse of this triangle because it's the longest side. This is the hypotenuse of this triangle because it's the longest side. So, for these two triangles, they both have a right angle, their hypotenuses are equal, and another side is equal. This side is equal in both triangles, so these two triangles are congruent by the RHS test. So, let's look at these two. So we have 1, 2 pairs of sides that are equal and a pair of angles. But notice this time the angle is not between the two sides. If I wanted to use the SAS test for these two triangles, I would need this angle and this angle. They would need to be equal. To use the SAS test, we need 2 pairs of equal sides, but we have to have the angle in between. Because it's not the angle in between, I can't use the SAS test. Now, I can't use any of the others equal. I can't use AAS because I don't have 2 pairs of equal angles. I can't use RHS because these two triangles are not right-angled. And I can't use SSS because I don't know if these two sides are equal. So actually, I can't use any of the tests. I can't be sure that these two are not congruent. They could be congruent, but I'm just not sure. So what I just say is there's not enough info here. I can't tell whether or not these two triangles are congruent. All right, let's now look at using congruence to find unknown quantities. So I'm telling you that these two triangles are congruent, and we're going to use this to find the value of x. So as I said before, if I know that two triangles are congruent, that means pairs of corresponding angles are equal. It also means pairs of corresponding sides are equal. So to find x here, I just need to find its corresponding or matching side in this triangle here. Now that can be tricky. You might not know, oh, have I reflected or rotated this shape or whatever, but what I'm going to do is look at what it's opposite. So see how x is opposite or facing the dot? That means its corresponding side in this triangle is the one that's opposite or facing the dot. X is corresponding to the 5 centimeter shape. So that just means x must be 5 centimeters because corresponding sides of congruent triangles must be equal. So let's look at these two triangles. So now I want to find x, which is an angle. So a lot of people look at that and say, okay, x is 55 because it's the one on the left. But I need to look a bit deeper. I need to find which of these angles corresponds to x. So see how x here is touching the side with 2 dashes and 3 dashes? It corresponds to the angle that is touching the side with 2 dashes and 3 dashes. Actually, I flipped this triangle to get this one. So the 58-degree angle corresponds to this one. The 55-degree angle would be over here. The 67-degree angle there. So in this case, x is actually corresponding to the 58-degree angle. They must be equal because corresponding angles of a congruent triangle must be equal. Now, this I know is going to get confusing because I'm using the word corresponding to mean something different than on the first slide. On the first slide, I talked about corresponding angles of parallel lines. Remember, that was the F shape, and these two angles are corresponding. But I don't mean that here. When I say corresponding angles are equal, actually mean matching angles, the angles that match. So sorry for the confusion, but unfortunately the word corresponding is just used in both cases. All right, let's now move on to unique triangles. So when we say a triangle is unique, it means you can only draw one triangle with those measurements. Any other triangle you would draw would be congruent to the first one. So to determine whether or not a triangle is unique, you just apply any of the congruence tests. Okay, probably doesn't make a lot of sense. What do I mean here? So let's say I'm asked to draw a triangle with side lengths 8, 12, and 16 centimeters. That triangle would be unique. It would be unique because of SSS, the SSS test. So I'm going to draw one. I'm not going to draw it to scale. That would take too long, but I am going to label it. So I'll draw this triangle, and this would be the 8 centimeter side, 12 centimeter side, and 16 centimeter side. This triangle is unique because if you were to draw your own triangle with sides 8, 12, and 16, it must be congruent to this one. It would be congruent by the SSS test. So you can't draw another triangle with these measurements. And when I say you can't draw another, you can't draw one that's not congruent to these. You can't draw a different triangle. Remember, congruent triangles are the same triangle. You cannot draw another triangle with these side lengths that is not congruent to this one. So if I ask you to draw a right-angled triangle with an angle 45 degrees, a side length of 10, it's actually not unique. You can draw more than one triangle with these measurements where the two triangles aren't congruent. I can actually draw two non-congruent triangles with these measurements. So you might be thinking, well, hang on a minute, it's right-angled, so that's one angle, 45, that's two angles, and a side. Wouldn't this be unique by the AAS test? So remember, for the AAS test, it has to be two equal angles, but it has to be a corresponding side. So I can draw two triangles with these angles, but the sides will not be corresponding. So we figured out on one of the earlier slides, if you have a triangle with a 90-degree angle and a 45-degree angle, it must be a right-angled isosceles triangle. So I've drawn here two right-angled isosceles triangles. So I have two options here for this 10-centimeter side. It could be the longer side, the hypotenuse, or it could be one of the shorter sides. The shorter sides must be equal in both triangles because it's an isosceles triangle, because it has two equal angles. This angle must also be 45, this angle must be 45. So I could put the 10-centimeter side here. It could be one of the shorter sides, or 10 centimeters could be the longer side. So these two triangles are not congruent, even though they have two pairs of equal angles and a pair of equal sides. In this triangle, 10 centimeter is the longest side, and it's opposite or facing the right angle. In this triangle, the 10 centimeter side is one of the shorter sides, and it's opposite or facing a 45-degree angle. This side will also be 10, facing a 45-degree angle. So that's why this triangle is not unique. You can draw triangles with one angle 45, one angle 90, and one angle 10 centimeter. You can draw triangles that are not congruent. All right, let's look at our final topic, which is using congruence in quadrilaterals. So we can actually use congruent triangles to prove or explain things that are true about certain quadrilaterals. So for example, let's use congruent triangles to show that a kite has a pair of equal angles. So from my previous slide, you remember that a kite is a shape that has two pairs of equal sides, but the equal sides are touching each other. So a kite is also called a diamond because that's exactly what it looks like. So this is a kite. How can I use congruent triangles to show that it has a pair of equal angles? Well, what I need to do is first divide this into congruent triangles. So if I draw a line down the middle here, I have two congruent triangles. So I'm going to give vertices names. So I'm going to call this A, B, C, and D. So I'm going to write a congruent statement. I'm going to write this triangle and this triangle are congruent. So this first triangle, I'm going to call triangle ABD. I need to use the triangle symbol to distinguish from angle ABD. So triangle ABD is congruent to, so you use these three lines, means is congruent to the other triangle. So A, this angle here corresponds to the angle at C, so because I wrote A first, I'm going to write C first in the next one. So B corresponds to itself, and D corresponds to itself. So this is my congruent statement. Now I'm going to write the test. The test I use is SSS. So I've just said this triangle and this triangle are congruent by the SSS test. They have two pairs of equal sides, and this third side is common, so it's also equal. So because this triangle and this triangle are congruent, corresponding angles, remember when I'm talking about corresponding angles of congruent triangles, I mean matching angles. So because these two triangles are congruent, matching angles must be equal. Those two angles must be equal. So therefore this angle here is BAD. So the angle's at A, so A goes in the center. Angles always have three letters. Angle BAD is equal to angle BCD. And again, the reason that they're equal, they're corresponding or matching angles of a congruent triangle. So I'm done. That's exactly what I wanted to prove. I proved that this kite has a pair of equal angles. So let's move on to the next one. So diagonals of a quadrilateral bisect each other. The shape must be a parallelogram. So I'm going to start by drawing a diagram to make things easier. So I've drawn my shape like this, and once again, I'm going to give vertices names A, B, C, D. So now I'm going to draw in the diagonals. So remember, diagonals are lines that join non-adjacent vertices. So that's one diagonal, and that's another diagonal. So I'm going to call vertex E the point in the middle where they meet. So, I was told the diagonals of this quadrilateral bisect each other. Bisect means cuts in half. So that means this side and this side are equal because BC, this diagonal, was cut in half. It also means this side and this side are equal because this diagonal was cut in half. So we also know from previous slide that this angle and this angle, so this one here and this one here, must be equal because they are vertically opposite. It also means this angle here and this angle here, the two x's, they are equal because they're vertically opposite. We can't say for sure that this angle and this angle are equal. We don't know that all four of these angles are equal to 90 degrees, but we do know these two are equal and these two are equal. So now I'm going to write a congruent statement for this triangle and this triangle. So I'll call this triangle ACE, and that is congruent to, so once again I've got to use the three lines. Triangle, so in this one, these two angles would be equal, so because they're alternates, A would correspond to D, C would correspond to B, so alright, it's second, and E corresponds to itself. So the reason that these two are congruent is the SAS test. Now I'm going to do the same, writing a congruent statement for these two triangles. So, because these two triangles are congruent, this side and this side must be equal, because they're corresponding sides of a congruent triangle. So AC must equal BD, and because this triangle and this triangle are congruent, AB and CD must equal each other because they are corresponding sides of a congruent triangle. So I've actually shown that ABCD has two pairs of equal sides. So that means ABCD has opposite sides equal. These two sides and these two sides are equal, and that's enough to prove it's a parallelogram. Remember on the previous slide when I went through all the quadrilaterals, we decided that if a four-sided shape has opposite sides equal, it's a parallelogram. So that's why knowing the definitions of quadrilaterals is really simple. I don't need to prove anything else. If opposite sides are equal, the shape must be a parallelogram. It means that these two must be parallel and these two must be parallel. But I've shown all I need to show. Alright, thank you so much for tuning in. Sorry for the long video, but best of luck studying. You're a superstar, you'll ace it. This has been the luckiest maths teacher in the world. Have a great day.